Last class, we covered chapter 12. Also, if you missed, well, I don't think anyone online or in class missed it, but a lot of people missed the attendance problems. But if you did miss it, I didn't take off, but we covered it last class. Chapter 13. So we covered chapter 12. Today we'll cover chapter 13, and then there is a group assignment. I don't think I put it in. Oh, I did put it in. There's a group assignment on Friday. Is there any questions on anything so far? So a contingency table looks like this. One going across males, next row is the males. So all the way across, there's 8,068 females enrollment, and it goes across. This is 5,355. This was the UMass Boston enrollment, and then going down is the undergraduates and the graduates. Females that are undergraduates were 5,680. Males were 4,328 for a total of 10,008 undergrads. Questions on reading it? If a student is chosen at random, find each probability. When a student is chosen at random, then you're always dividing by your total. Sometimes we'll have, and we'll be on like, is a female undergraduate. That's a little bit different than if it's of all students. Well, no, should say given. Okay, this one has it. Those get a little bit different. So for the first three, we're assuming it can be any divided by the total. So we look at the first one. The student is an undergraduate. Remember when we do probabilities, we take the total in the group that we want divided by all of them. So in this case, the student is an undergraduate. If we go in this column, there's 10,008 divided by the total. So if we're taking any one of our 13,000 students at random, the probability is an undergraduate, the total males and undergraduate is 10,008 out of the total. You can use, unless it specifies, decimal, percent, or fraction. You're getting almost 75%. If we use the decimal, or multiply that by 100, get the percent. Any questions on it? The probability a student is a female. So what would our fraction be? Anyone? Well, we know we're dividing by 13,433. What should be on the top? Because you want the total number of females. So we have 13,433 people. We're going to pull one out. What is the probability it's a female? Well, we would go across because we want undergraduates and graduates, so it'd be the total, 8,068. Divided by the total. %60.1%. But the fraction is fine on these. When we get into the tests, the next one, it'll have a true positive, true negatives. Those are all written in percent, but the other ones don't really matter. The probability a student is a female undergraduate. So we're picking any student at random. What's the probability that they're a female undergraduate? Yeah. Because we're picking any student at random. The probability they're a female and an undergraduate would be right here because it's where they overlap. Any questions on that one? Any questions before we move to the next one?
But I don't have to divide it, or do you go ahead and divide it, do it a fraction, or?
Oh, you mean for the last one?
Yeah.
It's up to you. It could be the fraction, the decimal, or the percent. Any one of them is fine. Spaces. The next one, it says find the probability it's an undergraduate given it's a female. When you're given a certain thing, then you ignore everything else. So we're given it's a female. We're only going to use that row. So we already know it's a female. We can throw all the males out. Then we wanted undergraduates. So the undergraduates are 5680 out of the 8,068. We already know it's a female. We can get rid of the other part. So when something is given, only use that row or column. Any questions on that? So this one that we just did, the probability it's an undergraduate given it's a female, will that be the same as the probability it's a female given it's an undergraduate? No, because they're not the same amount. Because if we know it's an undergraduate, then we're only, I don't know if it'll let me just, oh, it did. You only want to use that column. So when certain things are given, that row or that column. Probability undergraduate column, females are 5680 divided by the total in that column. Oops. Wait, repeat that.
Oh, yeah, that's it.
Oh, yeah. Yeah, I had put the note in there in case someone was, I don't know. I had all the answers in here. I must not have deleted that part. I should have. And the note kind of tells you that. On a test, you wouldn't be given the note. I only had my answer key, so I just forgot to delete that. But is there any questions on that? We're gonna, I think that's, yeah, that's the last. Any questions? We're gonna do another one. A person takes a test to see if he has cancer. Here's a possible outcomes. You have cancer and the test says no. Now, notice the right here, the true positive, true negative, false positive, false negative. The positive and negative, that's what the test says. So the test either tests you positive or negative. True and false is whether the test is right or wrong. So if you had cancer and the test says you do, then that's a true positive because you tested positive and it was true. Whereas if you didn't have cancer and the test says you don't have it, the test is going to say negative and it's true. If the test says you do, but you don't, the test is positive, but it's wrong. So always think positive and negative is your test, true and false as if it was right or wrong.
True or false if the test is wrong?
I guess you don't unless the person still has symptoms or they send them for further observation.
Would it be given on a test? Would they tell us if it was wrong, or is that just for?
They've done enough tests that this study, they probably did the tests and then sent them for more observation so they could make sure if it was true or false. I don't know all about this one because this one was from, I think this was from your book. But yeah, they would have to send it and.
I meant for our test, like,
Oh.
it's a question, would you say the test was wrong, or?
Yeah, I would give you, I'd probably say what's the probability of a true positive?
Okay.
So then you would use the table and find it. Yeah, no, I'd give you enough information. I see what you mean now.
The positive and negative determines
What the test said,
okay, and false is.
if it was right or wrong.
Okay.
If you think about, I'm sure everyone's had a strep test. When they call you, they tell you if it's positive or negative. But if it was a quick study done in the office, they still send it out for another test because it's so high that it's wrong. And strep throat cannot be, it doesn't just go away. You have to have an antibiotic if you have it. So then they have to take a second test because they've done so many studies that they know that it could be wrong. And that's kind of like this. On these ones where negative and it was wrong, positive. They didn't know it was wrong until they did more tests.
Any questions though on what they mean? Now, I always put my test positive and negative going across for two reasons. One, then this table is always correct. They're always in that position. But the other reason is because when we're finding these probabilities, then you divide by the ones on the bottom. And so then it's easier to remember. So whenever you're setting one up, if you do have to, for the most part, I usually put where I want things. Going across should always be what your test said. And then it's easier to find your percents. And if the test goes across, then the true positive is here, because in this case, a test for diagnosing depression was given. This one here says the test said yes, so positive, and it was correct because you are depressed. True positive. Going across, this said the test was positive, but you're not depressed. That's your false positive. So if you do forget, you can figure out where they go as long as you understand them, but I will always make the test go across, so these will always land in those spots. So this would be your, I'm going to just use TP for true positive. This would be your false positive. False negative. So they will always be in the same spot. So memorize where they're at or be able to figure it out by reading the problem. Any questions where they are? Okay. The first column is people who are depressed. The second one would be people who are not depressed. I wrote down finding them, but then I put them down here. I'm not sure. So we want to find the true positive and the false positive. If a person is depressed, what's the probability he is diagnosed correctly? That's what a true positive means. Notice it's given the column. What's the probability the test is correct? That's a true positive. So if we already know they're depressed and we want the probability that the test was positive or correct, that would be a true positive, 31 divided by 81. So whenever you're finding true positive, false negative, and true negative, you're dividing by the total below it, because it's using that given part. So a true positive is assuming the person is depressed. So it's 31 out of 81. And these are written as percents.
You only use the depressed row if it didn't have the given in it.
When you're working with these, you always assume that, like this first one, these two would all be assuming you have cancer, and these two are assuming you don't. So anytime you're finding a true positive, false negative, false positive, and true negative, you always use the value below it. You're only using that column. I thought the air was getting turned on. So true positive is if the person is depressed, what's the probability they're diagnosed correctly? A false negative is right here. So the person is depressed. We want the probability, it says they're depressed given they are not depressed. which means false negative. False positive. Oh, I was reading the wrong one. False negative. Okay. False negative rate. Probability test says you're not depressed given you are. Because that's right here, you're going to use 50 divided by 81. Trying to understand the words is a little more complicated than remembering to divide by the bottom. You only need to divide by the bottom as long as your test part is going across. So always make sure I will do that for my class, but if you're reading any and the tests go down, then it's going to be the opposite. So you want your test to always go across. So false negative, which is here, would be 50 divided by 81. And you do want to write these rates as percents. $61.7. Any questions on that? Go ahead and find the false positive rate and the false, or wait, which one didn't we do? True negative. You're getting 11.7% for the false positive. And 88.3 for the true negative. Any questions on finding the values?
How do you write that on the test? Do you just put false negative rate, or do you put the probability test? Because I like it when it says false negative, but when it's written out, it looks more.
I would not write it out.
Okay.
Yeah, I would just say find the false negative rate. Yeah, I think sometimes that being written is a little more confusing. And that's why I always make my test go across. But it helps you know what part is given. But for our course, I think it's easier just to make your test go across, then you always use the bottom total. Is it a good test? So if we look at people who are depressed, and it was correct, 38% of the time. Which means those who, false negative here, means they are depressed
but the test said they weren't. False negative was 61%, almost 62%. So 62% of the people who go there for help are sent away because they're told they're not depressed. Doesn't sound very good. Definitely not. Now, if they're using this in a school setting, maybe then the ones that were marked as not depressed, maybe they are depressed. Tested they were, maybe they test them again with something a little better so that they just have a quick one. I don't know, but if not, this isn't a very good one. Because then if we look at the true negatives, they're not depressed. Oh, that was the true, the false ones. These are the ones that are not depressed and it said they weren't, which was pretty good, 88%. But this 11% here, they're not depressed, but it's going to say they are. It's not a bad thing to get some help and make sure, but the biggest thing is that 62% of the people who need help are not getting it. That's the false negative. Any questions on that? So on a test, you'll definitely have to explain why it is or isn't good, and you use your true positives. Yes, it was last. Okay, let's look at. I kind of wrote a little paragraph about it. If not depressed, it's wrong 12% of the time. That's not too bad. But if a subject is depressed 62% of the time, they're not getting the help they needed. The ones for the group assignment are really interesting because, well, it uses the strep throat, but then it shows you the COVID tests and why they have the quick test, but you still should send away for the other. I put up a couple more problems. They're marked practice setting up contingency tables. So we'll set up a couple tables. I found them online this morning. So it says, use the given information below to make and complete a 4x4 table that displays all the information, including the total. Sometimes you'll see contingency tables where this total and the one going across the bottom is not there. So then you need to use those totals and write them in, or think about them when you're finding your probability. I always have totals. So we surveyed 200 people and asked them 2 questions. Do you support Trump and are you a Republican? And here's the results. So if we survey 200 people, where should that number be? The total in the very bottom right. Yep. One way of checking, when you add down and you add across on the totals, they should come to 200 or you did something wrong somewhere. If you round to whole numbers, sometimes it'll be off by 1. I think this comes out nicely. So a total of 110 people supported Trump. Where would that go? This first one. Because these are supporting, and there was a total of 110 people. And 90 did not. Now, we really didn't need that 90, right? Because we know going across it has to add up to 200. So this one had to be 90. So they could have skipped that part, but they didn't. 110 plus 90, 200. A total of 75 people are Republicans. Where would that go? So right here, because that's our Republicans. So 75. Whoops, can't hit enter. And yes, because this has to add up to 200, the rest would be 125. And you could just subtract 200 minus 75 gives you the 125. Not too bad. 50 people who are Republicans support Trump. Where would that go? Top left? Because it says Republican and support Trump, Republicans here, Trump's here, 50 people. Can we find the rest without more information? Okay, we'll go downward. So if we go down, 50 are Republicans, how many are not? Because we know that these two need to add up to the 110. So you can take 110 minus 50 and get 60. Okay, what if we go here? 25, we agree on that? Because we know going across adds up to 75, so 75 minus 50. And the last one,
65.
now you could have gotten this two ways. You could have went 90 minus 25, which is 65, or 125 minus 60, which is also 65. Any questions on that? What is the probability if we choose one at random that it's a Republican? We'll just do fractions so it's quicker. Or I guess we have a lot of time. Oh no, we have homework. Okay. So what's the probability it's a Republican? We'll do fractions. Republican. If we're choosing one at random, yeah. If we're choosing one at random, the total Republicans, so 75 out of the 200. What's the probability if we choose one at random, they support Trump? Yep, support Trump. If you go down, you have 110 divided by the total. Any questions on that? Okay, so go ahead and do the next two before we say. Okay, so it's a Republican given they support Trump. Does everyone agree with that? Because we're given they support Trump. So support Trump is this column. Their Republican is 50 out of the 110. Now you'll see, I can't remember if it's the homework or the group assignment, the way they word it, parts are given, but they don't say the word given. So you do have to be careful. I try not to do that on a test, but let's see. Probability support Trump given Republican. Anyone? Because it's given a Republican, then we know we're using this row. So it's 50 out of the 75. Yes. Depending on what was given. Any questions on that one? Go to another page so we could make some probabilities with it. Okay, so go ahead and fill out this contingency table. Oh, it's supposed to be air conditioning, but my husband took off all this week, so I don't know what got done. He works in the evening silent.
My office felt really cool, so. And it could also be, it was, what, 25 degrees this morning and cool on the outside. Okay, so go ahead and fill out.
Is it large? I can make it bigger if it's not. Everyone got it? Okay. So the total was 250. 180 said they have a cat. Where would that go? Mhm. So going across, having a cat, 180. 95 said they have a dog. So we just go where the dogs are, total 95. 52 have both a cat and a dog. Cat and dog, 52. Can we find everything else? I like to find my bottom and my totals first if I can. Sometimes you have to do more work inside first, but we could find how many people do not have a dog. 55? What we did was we took the 250 and subtracted 95 to get, say 155? Yep. How about how many do not have a cat? $250 minus 180 equals 70. Any questions? So then for this one, we know, we add down, it's a 95 minus the 52 to give us 43. Oops, that should be an equals. Any questions so far? Then adding across will help us get these ones. So it would be the 180 minus the 52. 128. And then 70 minus 43. 27. Any questions on finding them? If I choose one at random, what's the probability that they have cats and dogs? Any questions on setting it up or finding probability? Okay, I'm sorry. If I choose one at random, what's the probability, this was owning, right? Yeah. They have a cat and a dog. Oh, it's in the center. So choosing one at random, probability that I have a cat and a dog would be the 52 divided by 250. What's the probability own a cat given they own a dog? What would the fraction be, anyone? Yeah. Because given they own a dog goes down. The probability of cat, 52 out of 95. Any questions? Okay, so this is the homework. This is what's, there's two homeworks you had. We did one, chapter 12 on Monday, and we'll do chapter 13 today. Hopefully this moves. Suppose a study of speeding violations and drivers who use cell phones is produced the following fictional data. So using a cell phone while driving or not using it is going across. Your number of violations in the last year goes down. Go ahead and find the probabilities. I think, yeah, those are them. And these can be in any form, fraction, decimal, or percent, since they're not the rates. Good, everyone? Hopefully. Okay, we'll see. So the probability the driver is a cell phone user. So uses a cell phone would go across. So 305 divided by the total, 755. Yeah. Driver had no violations last year. Speeding violations, no speeding. So the driver had no violations would be 685 divided by the 755. Right, how about the driver had no violations and was a cell phone user? So no violations is here, 6, but they used their phone, yeah, 280 out of the total 755. Because nothing was given, so it's out of the total. No, nope, we still don't have the total until the next one. Now this one, I didn't really explain the or. I forgot to put one of those problems, I guess, in the review. Now we have to be careful with the or. So the driver is a cell phone user or the driver had no violations. What happens is if we do the driver, whoops, down, is a cell phone user. That's this column here, the 305. But if we also do driver had no violations, we're putting this part here we're doing it twice because we're going across uses the cell phone and we're coming down no violations. It's getting added in twice. So when you have an or, the formula is the probability of the one event plus the probability of the second event minus the probability of A and B. So if you have an or, the probability of A or B, you add the two together, but then you subtract that overlap because it was added in twice. So it is a formula you do want to know. You'll definitely see it on the in-class part of the final. So the probability, the driver is a cell phone user. 305 out of the 755. The probability they had no violations, 685 divided by the total. And then the probability of both, whoops, we need to subtract. So when it's an or, you have to be careful. If you just go by the totals, you're going to put this in twice. $305 plus 685 minus 280. $710 divided by 755. Or if you put the decimal 0.94 or 94%. Any questions on that? So or is the one you need to be careful of. Probability a driver is a cell phone user given the driver had a violation in the last year. So the given part, they had a violation. It's this one. So it's this column. A cell phone user. Did you get 25 out of 70? Oops. Yeah. Any questions on E? Okay, what did we get for F? Anyone?
405.
Does everyone agree? The driver had no violations given the driver was not a cell phone user. Not a cell phone user is the given part, so we're using this row. No violations, 405 out of, oh, I went the wrong way, hold on. The driver had no violations given not cell phone user. Oh, that's right. The driver had no violations given he was not a cell phone user. So we should have went across. Yep. So I always try and highlight the part, or like on a test, I would circle the part I'm using. That way I only use that. then I'd erase it and do the next one. But always look at the given part, that will section off for you, and then find the next one. Did everyone get 405, 450? Or if you didn't, you see what you did wrong. Took my phone out to take a picture, so I had that answer. Okay. Go ahead and set up the table, and then we'll go over the table, and then we'll do the probability. Oh. About 1,000, right? The number that goes here. Because it assumes that 20% of your students are using drugs. So the total needs to be 20% here. 20% of 1,000 means multiply. Put it as a decimal first. So the 1,000 times the 0.2, 200. If 200 use drugs, how many do not? Because we took 1,000 minus the 200 to get 800. Any questions on that part? She has read on the web that with a home drug test methods believed to produce reliable and accurate results, many of us overlook the cases of false positive and draw conclusions on suspects before confirming the results. Researchers at Boston University have found that drug tests may produce false positive in 10% of the cases. So false positive. Where's the false positive at? You tested positive, it was wrong, so that's here. So that's here. That's our false positive. It's 10%. 10% of the ones that don't, because remember, when you have false positives, all of those, you use the total below. So it's 10% of the 800. So did you get 80? So now that we have this, can we find the one below it? We know going down it needs to add up to 800, so 800 minus 80. $120. Any questions so far? Okay. We go to the next one, false negative, 15% of the time. Well, negative means it tested negative, which is the bottom row, and it was wrong, which means they used drugs. So 15% of the students are going to get away with it. To test the false negative for how many there are, though, what did we get? Anyone? Mm-hmm. Because we took 15% of the number below it, the 200. Which is 30. Which means how many true positives were there? 200 minus 30, 170. Any questions on that? And then you just add it across to get the totals. 170 and 80 is 250. And then 120 and 30 is 150. Oh, wow, 720. Be careful if you copied mine on this one here. It's 720. So 750. Another thing I always make sure is to, why is it not disappearing? I don't know. Well, let me, oh, there we go. Once you find them, always add your totals. So 250 and 750 is 1,000. 200 and 800 is 1,000. Just double check. Because that 120 I made here, then we would have caught it. Any questions on setting it up? So remember, anytime you're given those true positives or any of them, always have your bottom totals done and then use those. Okay, go ahead and find the proper probabilities. I thought there was another one. And the last two are paragraphs that you would write. Did everyone get the fill in the blank part yet? How many students are drug users? 200. Coming straight, use drugs, 200. How many drug users tested positive? So these are the drug users. This is positive, 170. If a student tested positive for drugs, what is the probability he is really on drugs? So if they tested positive, it goes across, and that they use drugs, 170 out of the 250. If a student tested negative, what's the probability he is drug-free? So testing negative would be this row. Drug-free would be the 720. 720 and 750. Does everyone agree with that? What would you think about the test if you were the false positive group? Well, okay, so false positive means you use drugs, but it tested negative. Okay, yeah. So you tested, wait, no, I said it wrong. False positive means you tested positive and it was wrong. You don't use drugs. So that would be this one. And what would that be? What's the false positive? 720. False positive. I got to go up one. This one's false positive. I even have it marked. 80 out of 800, 10%. Oh, I think it was even in the story. Yeah, 10%. So 10% of the people are going to be pretty upset, right? Because you could get expelled. Hopefully they would look at other things and maybe do another kind of test, but those 80 students should be pretty angry. How about the false negative group? Yeah, they'd be happy that they got away with it. But just write a few sentences about it. But is there any questions on false positive and false negative? made me think of my daughter. She's taking a physics class, and they have, well, it was supposed to be all take-home exams, 2 exams and a final take-home. She's like, this is going to be an easy class because I know the material, I just need more than an hour to do the test. Someone cheated on the first exam. And so instead of just, because the whole test was put on Chegg. So then they had to take the next test in class, and she don't know what he's going to do with the final. But she's like, an hour, if I had more time, maybe I could have finished that last problem. But she only needs like a 20% on the test and a 20% on the final because there's so much homework in there. But still, that's aggravating when you get, and the same thing here, then she finds out people are using drugs, so then everyone has to take it, and 10% of them didn't. So it just made me think of that. So something like that is what you could write in there if you had that kind of a situation. Okay. I've talked about this a little bit. An article headlined "Happy Halloween, Kids Who Eat Candy Every Day Will Grow Up to Be Violent Criminals" in the October 2nd, 2009 Daily Finance begins. Quick, hide the candy jar. Feeding your child candy every day could help turn Junior into a violent criminal, according to a large study in Britain, which found that 69% of participants who committed the crime are violent by 34 and had eaten sweets. So this is, I just like to highlight where certain things are, it's easier to find. For 4 decades, researchers from Cardiff University in Wales have studied nearly 17,500 participants. They learned that 10-year-olds who munched on sweets daily were significantly more likely to have been committed a violent crime by 34 than those who had an occasional treat. You can even find it online. There's a lot of studies that talk about it. There's even a lawyer that talks about it and how he's used it in a case. Not all children chocoholics had gotten into serious trouble when they were older. Of the participants who hadn't turned out to be violent, 42% had also eaten sweets. Build a contingency table. Now, in the study, I couldn't find out how many were violent and how many weren't. I would assume if they were going to do this, they would have split it in half. So we're going to assume half. So building the contingency table, assume half of the group committed a violent crime and half did not. So, total. Oh gosh, then my household's in trouble because there's candy sitting out on my thing all the time. But it doesn't get eaten until my nephews come over. Yeah, I finally got rid of the Halloween candy. I just filled the rest of it in a bag and gave it to my brother. It's probably gone already. I gave it to him Monday. They just... Yeah. I think that when you don't let them have it, they want it more. Mine's just been sitting there. They grab one once in a while because they know it'll always be there. They don't have to. Okay.
Don't let them have it.
Yeah. Because they need it. I don't know. I think it has nothing to do with that, but someone built a pretty good study on it. So we're going to say half of them are violent and half are not, because if you're doing a proper study, you should break them up equally. I don't know how I made this table. Okay. 69% of the participants who had committed violence had eaten sweets. I think that would be a true positive, huh? Because of the ones who committed violent crimes, of the participants who had committed violent crimes, so given they committed a violent crime, they ate chocolate. So 69% of the violent ones. So that would be of the 8750. Yeah, we will round. It's up to you. You could leave the half because it's just an estimate, but I think it's easier if we round it. 0.69 times 8750. So does everyone want to round? Okay. 6038. Now, because we're rounding this, if we have to round on, I don't think we have to round on the second one, but if we had to, we could be off by 1, which is okay. Okay, so we know that one. We could figure the nose below it, right? I don't understand how I made this. There we go. So then this one would just be your 8750 minus 6038. Of the participants who hadn't turned out to be violent, 42% had eaten sweets. So weren't violent would be this column, had eaten sweets, so it would be here would be the 42% of the ones that were not violent. So 0.42 times the 8750. $36.75. So then we know the total adding across. For they didn't eat sweets and they didn't commit violent crime, are you getting 50.75? Adding across. So I added across and got 7787, and then I'm gonna add down and make sure they match. Which they do. Any questions on any of the values? Okay. How many violent adults ate candy? So violence here, 8 candies here, so 60, 38 right here. How many non-violent adults ate candy? $6.75? Okay. Everyone agree with that? So it says 69% of violent criminals ate candy all the time. Write a paragraph about how you feel about the study. Now, you can use the percents, you can just say what you think about the study, but it's just a little paragraph about how you feel about the study. %69 of violent criminals could get off. But I'm sure they'd have to prove that. How could they prove that they had candy every day as young? Look at the copies. I don't know, but you can look up online. There's a lot of more information on this problem. Any questions on anything? Okay. On Friday, we'll have a group assignment with contingency tables, and that's the last, this is the last of the material. Any questions of those who are online? I was